Hi friends, welcome to the conference presentation. My topic is an Optisystem simulation for indoor visible light communication system, and my name is Alvin Paulos. I'm an MTech communication system student from Christ University, Bangalore. So during the presentation I start with a small introduction and abstract discussion and discuss about the VLC simulation using Optisystem simulation tool and the experimental result from my studies and conclusion and some of the reference I used for this study. So when we start with our abstraction discussion, the visible light communication is one of the key area in wireless communication, which works similarly to fiber optics links, except the beam is transmitted through free space. While the transmitter and the receiver must require line of sight condition, they have the benefit of eliminating the need for broadcast right and buried cables.
And VLC communication system can be easily deployed since they are very inexpensive, small, and do not require any radio interference signals. The detailed study of VLC is found that it can be used for many areas. The application includes vehicle-to-vehicle data transmission, position detection, intelligent transport system, image sensor communication, internet access, and audio and video transmission. And in this paper, I discussed about performance analysis of visible light communication. I created an indoor visible light system, and the performance is analyzed. In introduction area, firstly, we thought the idea got from one scientist, Alexander Graham Bell, in 1880. His experiment photophone and a device transmitter to transmitter. He transmitted a sound signal using a beam of light. But the experiment was not success. The interference and the other participants in the experiment was a failure.
So the idea of light communication also evolved from Morse code transmission. So with the invention of LED, the idea of using light as a communication medium has started again. In VLC, the light is used between 400 terahertz to the 800 terahertz of frequency, and wavelength is between 400 nanometer to 700 nanometer. So now the light we use in our daily life can not only be used for providing light but also for communication. So next is like our VLC simulation using Optisystem simulation tool. So Optisystem is a comprehensive software design suite that enables users to plan, test and simulate optical links in the transmission layer of modern optical networks. So in the experimental setup, we consider two scenarios: LOS propagation model, non-LOS propagation model. And in the case of non-LOS propagation model, we used one LED non-LOS propagation model and two LED non-LOS propagation model. So here is the diagram of non-LOS propagation model, and we consider one LED and the room size is 100 meter length and 100 meter width, and the angle we consider as like 22 degree and 25 degrees. So here is the simulation architecture we used for our experiment, and here is the result. So our input result and output results. So in the non-line of sight propagation model, we designed the same room environment and we consider the non-line of sight condition with the following measurements like the L1, L2, L3, this type of meter length and the angles. So here is the architecture we used for the simulation, and here the input and the output results. So in the case of two LED non-line of sight propagation model, we use the this design, and here is the parameter we used for each scenario: LED1 and LED2. So here is the architecture we used for simulation, and here is the input and output result. So in the conclusion, in this paper we analyze the VLC system using Optisystem simulation tool. So in this analysis we consider two propagation models: LOS propagation model, non-line of sight propagation model. So in LOS propagation model, in the receiver, and we regenerate the approximated transmitted signal, and in the case the distortion affected in the transmitted signal is less, as we will get transmitted signal with the less noise. In non-line of sight propagation model, we consider two cases, and if we need a system with a low bit rate and less noise affected, selected the LOS propagation model, or one LED non-LOS propagation model. So if we have to send more data with less time, selected to LED non-LOS propagation model, or for higher bit rate go for n LED non-LOS propagation models. So following are the references we used for our studies.